Hi, and welcome to the section, Numerical Computing with NumPy. Let's start with the first video of this section, a primer to vector computing. One of the most important take-home messages of this chapter is that vector operations on ND arrays are much faster than Python loops. Most numerical computations should be done with vector operations in NumPy instead of Python loops. Let's illustrate this particularly important point by showing two ways of computing the sum of two vectors, in pure Python and with NumPy. Let's first create two vectors containing 1 million random numbers each. We use the native random module in a list comprehension. We compute the sum of these vectors with another list comprehension. The zip built-in function allows us to loop over the two vectors simultaneously, as we used it here. How long does this operation take? Let's use IPython's timeItMagic command to find out. It may take a few seconds. Done! As you can see, it took around 117 microseconds. Now we perform the same operation with NumPy. The np.array function can convert a Python list into an ND array. Although the list1 and arr1 contain the same data, they don't have the same data type. In the next line, continue writing. Type list1, type array1, and array1.shape, array1.dtype. Computing the sum of the two arrays is particularly easy with NumPy. The plus character directly works with ND arrays of the same shape. Sum array equals array1 plus array2. And now, let's get the sum of array with three values. How much faster is NumPy over pure Python here? Let's find it with the timeItMagic command. This is about 45 times faster. Generally speaking, getting one or several orders of magnitude of speed improvements between pure Python and NumPy is not uncommon. We'll explain the technical reasons of this below. In the meantime, just remember that vectorized operations with NumPy are much faster than Python loops. Every time you're tempted to write a Python loop, see if you can use NumPy instead.